Welcome to yet another edition of the AI Digest Weekly. Today we are going to be looking at the top 10 research papers in the domains of artificial intelligence, including large language models, computer vision, and natural language processing. And we are going to be looking at these papers in the week 13, that is the week of March 27th to April 2nd. Let's look at the first paper. It's called Secret Keeping in Question Answering. Now, the focus of most question answering efforts has been to improve accuracy, but there has been little research on the privacy of the question replies. These QA systems, which have access to private companies' confidential information, must include the confidentiality features to prevent unauthorized disclosure of sensitive information. However, the memory of the training data in these large language models is most likely to retain confidential information due to fine tuning that can compromise the privacy. To address this issue, a modular architecture with secret keeping subsystem that has that only has access to a data store containing secret information is proposed to prevent information leaks. The proposed system uses a quality assurance system to detect the exposure of secrets and has evaluation measures to assess its efficacy. So, how the system works is a user asks a question to the question answering model here. It also asks the same question to the secret keeper system. Now, the secret keeper system has access to this secret store, which contains the confidential information to the of the company. All right. Now, each of these two systems provide an answer. So the answer is provided by the QA system, and the answer is also provided by the secret keeper systems. These answers that are provided are converted into sentence embeddings here, and then a cosine similarity match is done between those two answers. Now, if the cosine similarity match, which means that is above a certain threshold, which essentially means that they are the same answer, then that particular question is blocked because that indicates that there is a presence of a secret or there is a presence of a confidential. Okay, the next article we are going to be looking at is called Reflexion, an autonomous agent with dynamic memory and self-reflection. Now, in this article, the researchers from the Northeastern University and the MIT have developed a self-reflective natural language agent using an approach called Reflexion. Now, this agent has the ability to reflect on its own performance and improve its decision making skills in unfamiliar settings. The team tested the agent on two benchmarks, which is the text based AlfWorld and the question answering Hotbot QA, and achieved significantly better results than a baseline agent. This reflection agent can identify ineffective actions and hallucinations, leading to a 97% success discovery rate on the AlfWorld benchmark. The team believes that this approach can be applied to more complex tasks such as generating novel ideas, investigating unseen state spaces, and constructing precise action plans. Now, the figure here shows how a reflection can be added to any decision making approach. The next paper is called Artificial Muses. Generative artificial intelligence chatbots have risen to human level creativity. Now, the article discusses a recent research paper that compares the creativity of humans and generative AI in generating ideas using the alternative uses test or the AUT. The researchers evaluated that the quality and the quantity of ideas generated by 100 human participants and 6 generative AI chatbots, including the ChatGPT and the DALI. And the results of the study found that there was no significant difference between the creativity of humans and AI in terms of the originality and the fluency, except for a small percentage of human participants who are found to be more creative. The study also found that the GPT-4 outperformed all the other generative AIs in the EOT except for one prompt where it ranked second compared to the humans. Overall, the study suggests that AI has matched the human creativity in generating ideas. The next paper is called Announcing OpenFlamingo, an open source framework for training vision language models with in context learning. Now, this paper talks about OpenFlamingo, which is an open source framework designed to democratize access to the state of the art large language multimodal models, LLMs, and make them more accessible to the researchers and practitioners. Now, this is a reproduction of the DeepMind's Flamingo model. It provides a Python framework to train Flamingo style LLMs, a large scale multimodal data set, and in context learning evaluation benchmark framework. The first version of the Open Flamingo 9B model or the 9 billion parameters model is based on the Llama and is trained on a massive data set comprising of around 75 million documents, including approximately 400 million images and 38 billion tokens. The project's open source approach and large scale dataset offers a way for researchers and practitioners to develop more sophisticated models for vision language tasks, such as image and video captioning, image retrieval, and question and answering. So, if you look at the examples here, what this model can do is it can interleave the image before each corresponding text. Also, it can interleave the image after each corresponding. So the next article we are going to be looking at today is called Cerebras-GPT, a family of open, compute efficient large language models. Now, if you look at the page, Cerebras System Incorporated has announced that it has trained and released 7 big large language models for generative AI, and which are going to be made publicly available under the open source Apache 2.0 license. Now, these models are called the Cerebras-GPT models, which are here, and they have been trained using the cutting edge methods and the publicly available data sets. Now, these models have varied size starting from 111 million parameters to 13 billion parameters. And the interesting part is that they have been trained without the GPU based technologies. Now, the models were tested on various language-based tasks, including sentence completion and Q&A sessions. And it was found that these methods, these GPT models uses the publicly available pile data set, and is computationally much faster, in training of the large language models. So if you look at the comparison of this the Cerebras GPT model comparing to GPT-4, DeepMind, Meta OPT, and Pythia models, the model architecture is open. The training data set is open. It's a publicly available data set. The model weights are open. The checkpoints are available, and these models take very little time to train. They are much cheaper and consumes much less energy as compared to the other LLM. Hi everyone, the next article we are going to be looking at today is called Adapting Pre-trained Vision Language Foundation Models to Medical Imaging Domains. Now, researchers at Stanford have investigated the potential of stable diffusion models to produce synthetic medical imaging data to assist in supervised machine learning pipelines where the training data is scarce. Now, what the team did was they evaluated the limits of these large vision language foundation models for medical imaging concepts and used the chest x-rays from 2 publicly available databases. Now, they proposed 3 fine-tuning techniques for the stable diffusion model in the radiology domain to generate synthetic images based on the text prompts. The results showed that the unit fine-tuning method achieved the lowest FID score. So if you look at here, this unit method, what is demonstrated here, it produced the most realistic results. What we are going to be looking at is called Wavelet Diffusion Models, or fast and scalable image generators. Now, researchers at the Win AI have proposed a new wavelet-based diffusion strategy to accelerate the speed of diffusion models. Now, the diffusion models, as we are aware, they produce high quality outputs from the random noise inputs. Even though the diffusion models have shown impressive results in generating realistic images, they've always been limited by their slow inference times. So, what the Win AI researchers have done is that they have used the discrete wavelet transforms at the feature level and at the image level to speed up the training and the inference time while maintaining the output quality. So, if you look at the picture here, uh, the denoising which is happening at the wavelet level, right? Instead of at the pixel level. So by using this wavelet decomposition in both image and the feature space, the researchers have created a significant performance boost for the diffusion models. This article we are going to be looking at today is pretty interesting. It's called Meet X Turing, an open source tool that allows you to create your own large language models with only 3 lines of code. Now, in this paper, Stochastic, which is a team of machine learning experts, has developed an open source solution called X-Turing that makes it easier and faster for the users to create their own large language models. Now, X-Turing offers a versatile single GPU or multi GPU training framework that allows the users to train their models to the specific hardware configurations. It also uses memory efficient fine tuning techniques like LoRa to speed up the learning process and cut down on the hardware expenditures by up to 90%. Now, the team tested this X-Turing's capabilities using the Llama 7 billion parameter model and found that the training speed or the training time was reduced from 40 minutes to 20 minutes per epoch while using the LoRa plus deep speed or LoRa plus deep speed plus CPU offloading. Now, with its user friendly interface, as you can see here, it has got a UI playground uh, and the interface and the ability to fine tune such big large language models so easily. X-Turing is an excellent choice for both beginners and the experienced users. Article we are going to be looking at is called Llama Adapter Efficient Fine Tuning of Language Models with Zero Initial Attention. Now, this article discusses the development of an accessible and scalable instruction following model called Llama Adapter, now, which is an improvement over the previously developed Alpaca model. The Llama adapter is a fine tuning technique that transforms the Llama, which is a 13 billion or a 7 billion parameter model, into a capable instruction following model utilizing a set of learnable adaptation prompts that are adaptively injected into the higher transformer layers of the Llama. Now, this method helps the final model better follow the instructions and maintain the learning stability during the fine tuning, resulting in a model with only 1.2 million parameters. And it converges in less than 1 hour of fine tuning, with only 8 A100 GPUs. Now, the interesting thing is that the Llama adapter can also be expanded to accept image and textual instructions for multimodal reasoning. Look at the last article for today. It's called Colossal Chat, an open source solution for cloning ChatGPT with a complete reinforcement learning with human feedback pipeline. Now, the article discusses the increasing popularity of large AI models and applications such as ChatGPT and GPT-4, which have prompted a wave of technology development from academia and industry experts. However, the lack of open source models have left many curious about the technical details behind these models. To address this issue, what Colossal AI has done is it's provided an open source solution that includes a complete reinforcement learning with human feedback pipeline, the RLHF pipeline, open source training code, and data sets that can be used to build and train the large AI models. Colossal AI also offers an interactive demo that allows the users to understand how the technology works. The open source solution that is being provided by the Colossal AI can help lower the cost of building and applying the large AI models, protecting the core data and IP, and democratizing the access to this large AI models. Of this week's AI Digest Weekly. Thank you very much for joining me, and I look forward to meeting you next week. Have a good weekend.